Hi everyone, today we're solving a question minus log x to base x all in parentheses to the root of pi. Knowing fully well that this is the same question, there are quite a number of people don't even know where to start from. But we're gonna start from what is inside the parentheses first. We must note that, the first thing we must observe here, minus log of x into base x all in parentheses raised to the power of pi, and minus log of x to the base of x then raised to the power of root of pi. These two here are not just the same thing. That is, the left hand side is not equal to the right hand side. Definitely, if we're going to undo this right hand side, we're going to say, okay, applying the rule of logarithm to this part, and it's going to shift to the left side of it like this, minus root pi log of x into base x. And the next step to this, minus log of x to base x and to the power of root pi, the next step is going to be minus root of pi log of x to base x, which is not the same thing we have here. So we're not going to handle this left hand side with what we have here in the right hand side. That is why they are not the same thing. So I will know that they are not the same thing. Our focus should be what is inside these parentheses. And the first thing we're going to do here is that to remember that every log to its own base in one of the rules of logarithm is just equal to 1. That is one of the rule of logarithm. If I have log of 2 to base 2, actually I'm going to have 1. It's going to be equal to 1. Of course, that is a beautiful way to start. So minus log of x to base x all in parentheses raised to the power of root pi can now be written as minus 1 in parentheses all to the power of root of pi. At this point, the next thing I'm going to do is to look for a way I'm going to rewrite this minus 1. That is why my attention is going to be drawn to Euler identity. And the one I'm going to need now is the one that says exponential of pi I plus 1 equals to 0. So what if I bring this outside here? So I'm going to have minus 1 equals to exponential pi I. Exponential pi I equals to minus 1. Having this, what if I replace my minus 1 here with exponential pi I? Because exponential pi I equals to minus 1 equals to exponential pi I. What if I replace this minus 1 with this exponential pi I? So this my expression cannot be written now as minus 1 all in parentheses raised to the power of root pi now equals to exponential pi I, then all in parentheses to the power of pi, root of pi. And the only thing that changes here is this being substituted to this. So I'm going to continue the journey here. And the next thing is to apply one of the rules of indices to this power, the power inside these parentheses and the power outside the parentheses. If I have something of this nature, that is a raised to the power of m all in parentheses, then I have another power that is another exponent outside. This rule says I'm going to multiply the power inside the parentheses and at the same time the power outside the parentheses, which is a raised to the power of m multiplied by n. So if I do the same thing to my expression here, it becomes exponential of pi multiplied by I, then multiplied by root of pi. Definitely I'm going to relate pi to pi for sure, and if I bring that together, I have pi multiplied by another, that is root of pi, but this time around root of pi is still the same thing as pi raised by the power of half. That is pi raised by the power of half, then multiplied by I. Then what do I do to this pi together? Of course, I'm going to apply this. If I have a raised by the power of m multiplied by another base a raised by the power of m, so I'm going to have a raised by the power of m plus n. Having the same base, of course, the rule is valid. So if I do the same thing here, pi to the power of 1 is here, 1 is here, then half is here. So I'm going to add both exponents together. 1 plus half, that's going to give me 1.5. Yes, I'm going to have pi raised by the power of 1.5, and 1.5 is just the same thing as 3/2. Pi raised to the power of 3/2. Now that we've added this together, now we're going to have exponential of pi raised to the power of 3/2 I. So at this point, what am I going to do to this side of my expression? That will make me to make reference to Euler equation. What does it say? Exponential theta I equals to cos theta plus I sine theta. Looking at the expression that I have here, now I can say, okay, my expression exponential pi raised to the power of 3/2 multiplied by I can now be written in the same format as cos pi raised to the power of 3/2 plus I sine of pi 3/2. So finally I can say the question minus log x to the base of x, all in parentheses, to the power of root pi equals to cos pi to the power of 3/2 plus I sine pi to the power of 3/2 minus log of x to the base of x, all to the power of root pi is equal to cos of pi raised to the power of 3/2 plus I, then sine pi power of 3/2. Final answer. That is final answer. And just before you go, don't forget to subscribe, like, share, and if there is addition to this explanation, you can put that in the comment section. Definitely I'm going to respond. Thank you so much. I mean, I need you to do this, and this.